In this video we're going to consider colour. Now once you have a group of animals with a visual system with complicated eyes, they can start to differentiate between the different wavelengths of light that are coming through, which we know as the spectrum. But some animals see far into the ultraviolet and others have the capacity to detect infrared. Now colours in nature come in two sorts of varieties. So we've got the colour that comes from pigments, and pigments are involved with the selective absorption of light, like this feather. And then we also have iridescence. This is interference light, like you see in this peacock feather, where the very fine structures that you can only see with the electron microscope are interfering with the incident light and giving you these very vivid, bold colours. Now once you've got colour in your equation, it can be used in all sorts of ways. Some animals use it to advertise that they're, fertile and virile. Some that they're dangerous. Some advertise that they're good to eat, though those are normally plants with their berries advertising that they're ready and ripe. And they use that as a lure for animals to come and eat them and then disperse their seed with a ready-made packet of manure to go with it. And also there's recognition. Some species look very similar if you see them in profile, but once you add colour, you can differentiate them. And you can see that around the University Lake with all the different ducks that arrive. Sometimes they don't know the difference either, so you get these odd hybrids. But largely, some species use colour to recognise one another. Now I want to talk a little bit about aposomatism. And the organisms I'm going to start with are these burnet moths here, which have very bright colours on their wings. Now they're using that in what's known as honest signalling. They are sending out a warning to a predator that if they attack them, they're in for some trouble. Now with these burnet moths, it's because they are toxic, they've got poisons in them, so you don't want to eat them. But others, like skunk, will dissuade you from attacking them with a foul smell. And there are others which might want to fight back, like honey badgers. And so that they're very aggressive. This is honest advertising, and out of it comes two different sorts of mimicry, which we'll go to now. So there's mimicry where different toxic animals have the same sort of coloration. So here we might look, and these are not alive, but there's a wasp with its yellow and black coloration, and there's a bee with a similar yellow and black coloration. Both of these animals have poison, with venoms which they can inject into you. And there's a long list of animals which are black and yellow and toxic: hornets, wasps, bees, and so on. And that's called Mullerian mimicry, where they capitalise on a large number of creatures sending out the same honest signal that if you pick on them, you're going to be in trouble. There's also dishonest signalling, and that's called Batesian mimicry. And here we have a whole tray showing different Batesian mimics. So we've got the hornets, which are a member of the wasp family, the Hymenoptera. And they are toxic, and they've got a nice nasty sting, so you don't want to mess with them. But alongside them, you've got the clearwing moth. Looks very similar. So the moth has evolved to mimic the hornet. And there are bee beetles, and there are things that beetles that look like ants, and there are moths that look like bees. So within this whole area of colour, you have these honest signalling and dishonest signalling by which animals can protect themselves either by being toxic or by looking like something that is toxic. Obviously, if your predator, if a bird is in a whole area of hoverflies and eats them and finds that they're non-toxic, they're not difficult to eat, then they might start eating wasps and get a nasty surprise. So the ratio of honest signallers to dishonest signallers matters. But for these creatures, it's obviously been a very successful strategy, as we have both the honest signallers, their Mullerian mimics, and the Batesian mimics who are hitching a free ride on the toxicity of the others.